Welcome back, THS Chem Team. Today's topic is mass to moles conversions or moles to mass conversions. So we're going to take that topic of formula mass, and now we're going to start looking at this idea of converting it into a new unit that we're going to call a mole. Okay, you're going to need a calculator and your reference tables today to do this, so get those out and get them in front of you. And let's go ahead and get started. First off, a mole is a made up unit of measurement that we're going to use to identify 6.02 times 10 to the 23rd atoms or molecules of a substance. Technically, you can have a mole of anything if you have 6.02 times 10 to the 23rd of them. This number is called Avogadro's number. We're going to get more into this in class about what it is and where it comes from, but for today, what you need to know is that the mole is just a unit of measurement in chemistry. And think of it like a dozen. Instead of saying I have 12 eggs, you say you have a dozen eggs. It's a way to make really big numbers easier to keep track of. Since we're not going to be dealing with one or two atoms at a time, we're going to have huge numbers of atoms. We usually like to deal with them in terms of moles. So the mole makes it easier to keep track of these large amount of atoms and molecules. Okay, so it is basically a ratio. And there's also some other cool aspects to come up with this mole measurement. We talked about formula mass last time in these video notes, and if we have the formula mass or molar mass of a substance, that means we have 1 mole of that substance, or there is 6.02 times 10 to the 23rd particles of that. So if I had a mole of copper, I would have its formula mass of copper at the same time. So if I had that many atoms, I would have the mass from the periodic table. So it kind of works out in a good way for us, especially if we're going to start doing some calculations. Now, in the back of your reference table, you're going to see this equation. So most of the time in chemistry, for this class, whenever you're going to be calculating moles or mass using moles, this is the equation you're going to use. So you see number of moles, you see given mass, and gram formula mass, which we talked about last time. Sometimes the hard part is figuring out which part is which, but that's why we're going to do a few practice problems here to make sure we have the hang of it. All right, so here we go. Let's take a look. First one, what is the mass of 5.00 moles of sulfur atoms? So from the problem right away, I know that I have one value given to me, and that is 5 moles. So my number of moles in this case, and mole abbreviation for mole is just MOL, is going to be equal to 5. That means I'm going to have at least one other piece of information from my equation. So if I'm looking for what is the mass, this is the given mass, in this case, is my unknown. That means I should be able to find the gram formula mass, or GFM. Remember, if we're going to find the GFM of a substance, in this case we're dealing with sulfur, we're going to have to go to our periodic table to find it. So we're going to go to sulfur, which is an element in this case, so it's pretty easy to find. We just have to get its atomic mass from the table, and that's right over here. And we see that the mass of sulfur is 32.065, or we're going to round it today to 32. So let's go back to our problem. And we're going to say that sulfur has a GFM of 32 grams per mole. And that means we are looking for our mass is our missing variable. Okay, so we have two pieces. We're solving for the one missing piece, which in this case is given mass. Now that we know our pieces, we're going to plug it into our equation. We know that we have 5 moles is equal to mass that we're looking for divided by our GFM, which we just said is 32 grams per mole. Now once I see this, I know I'm trying to solve for that variable on the top for mass. To do that, I'm going to multiply both sides by 32 grams per mole. If I multiply by 32 on this side, that cancels. I need to multiply over here by 32 grams per mole. What cancels out now is the moles. I have 32 times 5, which is going to get me an answer where my mass is going to be equal to 160 grams because moles goes away. So that would be my final answer. So it's not anything more complicated than you have a new unit and you're doing some simple algebra to solve for the missing piece. All right, let's try another one. All right, so the second one. How many moles of iron atoms weigh 50 grams? So in the problem, I'm given 50 grams. Grams is a mass measurement. That means my given mass this time is 50. How many moles? So that means number of moles. That's my missing piece. So I need to solve for number of moles. So I should also have a GFM that I need to find. In this case, I'm dealing with iron atoms. So it's just an element. Again, I don't have to worry about adding a whole bunch of stuff up. I just need to go back to my periodic table, find iron, which is right here, and get its mass. So I have a GFM for iron of 55.845. Grams per mole. So I have all the information I need to be able to solve this. So now I'm going to just take it, plug everything into my equation that's given to me on my reference table. So my number of moles is what I'm missing. So moles is my missing variable. The mass that is given to me, or my given mass in this case, we determined was 50 grams. My GFM for my substance of iron is 55.845 grams per mole. So in this case, once I know where they're at, this is a lot easier because they're already where all I need to do is divide. I'm going to divide 50 by 55.845 to get my answer. When I do that, I know right away that looking at this, I'm going to get a number that's less than 1. So my answer is actually 0.895, which makes sense because 50 is less than 55. And my unit will be, grams are going to cancel out, it's just going to be in moles. And that's going to be moles of iron. So that's my final answer for number 2. 0.895 moles of iron, the Fe. Okay, so it's really just deciphering which variables you have and solving for the correct one. Here are 2 examples I want you to write down in your notebook and attempt to show your work and get to a final answer. Both of these are going to have compounds instead of elements, so you're going to have to add up their formula mass like we did earlier this week. Good luck. Bring any questions to class. Please attempt both of these problems.